Hello everyone, welcome to the video on Prodrug Concept. Now we all know about prodrugs. They are inactive molecules which are activated to a drug molecule. But there are different types are there. I will explain the types by answering a question given in Public Service Commission. So the following question is given in APPSC 2018 Assistant Professor Examination. Look at the question carefully. So the question says one of the following statements is most appropriate with respective to Estramustain. Now the options given are: it is a carrier linked prodrug, it is a mutual prodrug, it is a bioprecursor prodrug. Last one, it is both mutual and carrier linked prodrug. Now look at the question. See, the options will create kind of confusion when we don't have clarity about prodrug classes. Now understand them. I will explain in simple terms with one example. Understand this. Now, let us take the first one, carrier linked prodrug. Now, certain drugs, they do not have enough lipophilicity or they do not have enough water solubility. Or to change the pharmacokinetic or dynamic properties, a group is attached. Now, that group is attached with the help of ester linkase or amide linkase. The reason why we are using ester or amide linkase is it is very easy to cleave that. Take for the example, chloramphenicol succinate. Now, chloramphenicol water solubility is increased with the help of succinic acid. Both of them attached with the help of an ester bond, chloramphenicol succinate. The water solubility increases and with the help of esters, it immediately releases chloramphenicol as well as sodium succinate. Now look at them. This carrier is linked with the help of amide or ester bond and the carrier molecule do not have any activity. Sodium succinate do not have any activity. Chloramphenicol is antibiotic. So these type of prodrugs are called as carrier linked prodrugs. I hope this is clear. Let's move on to the next one. Now there is another prodrug type called as bioprecursor prodrug. You know, we all know the very best drug to treat Parkinson's is levodopa. Levodopa is also a prodrug. Levodopa crosses the blood-brain barrier, gets into the brain, there it gets converted to dopamine. Now how it converts? It converts with the help of a molecular modification in the structure. Look at the structures. Levodopa, levo form of dihydroxyphenylalanine. It is an amino acid. So from the amino acid, a carboxyl group is removed and dopamine is created. Molecular modification. Unlike ester or amidases, a molecular modification occurs. This is called as a bioprecursor. So bioprecursors are these things. Two types we have seen. Now the third one, mutual prodrug. Now understand this one. Mutual prodrug means, look at the example. There is a drug called as sulfasalazine, which is used to treat ulcerative colitis. Now ulcerative colitis means at the colon ulcers are there. The problem with the colon ulcers is drugs rarely reach the colon site. So this sulfasalazine is created. Now look at the structure. Sulfasalazine is sulfonamide and amino salicylic acid derivative. So what happens is when this drug is taken, it gets till the colon. In the colon, because of microorganism enzyme azoreductase, it breaks into two parts. One is a sulfonamide, sulfapyridine derivative. Another one is amino salicylic acid. Now see, the sulfonamide acts on microorganism and restricts their multiplication. This amino salicylic reduces the pain at the colon because ulcers are causing pain. Now, what has happened? See, both of them has got activity. This is what is meant by mutual prodrug. So both the components has got activity. One is analgesic, another one is bacteriostatic. They are linked with aza bond. It is not ester or amide kind of thing. It is not a carrier molecule. It is linked with an aza bond which is cleaved only at the colon and releases these two components. Before releasing, it is not active. Once it is broken into two parts, one shows bacteriostatic action, another one shows analgesic activity. So these are called as mutual prodrugs. Now look at the question is about Estramustain. Estramustain is estradiol attached with nitrogen mustard with the help of an amide bond. Now this is important one. So what is the requirement for carrier prodrugs? Ester or amide derivative should be linked. Here it is linked with an amide derivative. So it is a kind of carrier prodrug. But look at the components. One is estradiol, another one is nitrogen mustard derivative. Now this drug is popularly used to treat prostate cancer. So what happens is when it gets there, the estradiol acts as anti-androgen. Prostate cancer is aggravated due to testosterone stimulation. So the steroid is blocked by estradiol, and this nitrogen mustard breaks DNA so that multiplication is inhibited. Prostate cancer will be controlled. So with the linkage, it is acting as a carrier prodrug. When you see both the drugs are active, hence it is also acting as mutual prodrug. Now look at the option 4. It is both mutual and carrier linked prodrug. This is the answer because it has got both the parameters. Now think about this. In order to answer this question, you need to know the types of prodrug, and you must be knowing about what is an Estramustain is. So this is how the competitive examination complexity will be there. When you understand the concept, it is very easy to give the answer. So I hope this is useful. All the best.